All right, well, let's look at a problem that maybe shows addition just so you can see the difference. And then we'll start adding more numbers in so you can see what if I have more than one thing going on in a problem. All right, so in this problem we have addition so that we can see a different thought with phase shift. But would everybody agree that sine of x plus pi over 4 is still got an amplitude of 1? And there's no negative on the x, so it's not going to change that. And then since there's a 1 in front of x, we know omega is 1. So 2 pi divided by 1 is 2 pi, and 2 pi divided by 4 is pi over 2. So I now know that my x's are still going by halves. In fact, once you get to that point, before you even look at phase shift, you could come over here and you could go ahead and number your x's because you know what they're going by. But then when you look at that phase shift and you start talking about the phase shift and what it does, and you say x plus pi over 4 equals 0, x is going to be equal to negative pi over 4, so that means left, right? My graph's going to move left pi over 4 because it came out negative. And negative numbers on the x-axis move to the left. Now what this is going to do to our problem is make it go to the left of the origin, right?
How did it get a negative?
Because you got to subtract to get rid of adding. It's always the opposite. So I have to take pi over 4 off of each one of these. Now sometimes that can be more difficult than others because it depends on how much you know about halves and fourths. If you know a lot about halves and fourths, you might not even have to get a common denominator. But if you don't feel comfortable with that, you can get a common denominator. But you're actually subtracting fourths. All right, so as you go through and do these, you know, it's totally up to you if you get a common denominator or not. Because, like I said, a lot of people know stuff about fourths. But when you get down here near the bottom, sometimes there might be one or two you might want to do it with, and you might not want to do it with every one of them. I mean, clearly, 0 minus a fourth is negative a fourth. If you have a half and you take a fourth off, what do you get? Yeah, because it takes 2/4 to make a half. Exactly. 1 minus a fourth is 3/4. Those we're very familiar with. Now, we could even be familiar with 2 minus a fourth maybe. But this 3 pi over 2, if you don't feel comfortable with that one, then what you could do is say, well, let me change 3 halves to fourths by doubling it. And then that way when you take your fourth away, you can see it's 5/4. Now, let's see if that makes sense. What's the tops of my fractions going by in blue? They're odd numbers. They're going up by 2s. Everybody agree? So if you got the first 3 while the numbers were easy to do the math without the common denominator, you could do the pattern thing and say, oh, I see it's going by 2s on the top, so this one's 7 pi over 4, and you don't have to get a common denominator. But that's up to you. Sometimes you may not see that pattern and you want to just do the common denominator thing, especially if you can't get the first view from it. So now, here's what most students do incorrectly. That's what my table says, but guess what my graph has to have? Well, let's see. Here is negative pi over 4, and here is positive pi over 4. And there was a number in between there, 0, right? So that it's going up by 4s. So when you come over here, the next line is pi over 2. It's not 3 pi over 4 because it's got to go up by force. You're going to have to number some lines that are not on this table because you have to keep your scale by force. Because your table is by force. So it's not going to even use every one of them. It's only going to use every other one, but that's what you got to do. So keep that in mind that when you go to your table and you look at your scale factor of your original problem was by halves. But when you did the common denominator work, that changed the denominator. I don't number it by the table because that won't work. You cannot number by force on using odd numbers. You have to use every line by force. Now with the sign column, the 0, 1, 0, negative 1, 0 column, the amplitude was 1. So I'm not changing that. It's staying the same. And so when I plot, negative pi over 4 is 0, and then I go over to pi over 4 and go up 1, and then come back down to 3/4 is 0, and then come over here to 5 pi over 4 and come down negative 1, and then do 7 pi over 4 is 0. I missed that a little bit, but anyway. It looks like I've stretched my graph out, but I haven't. I haven't stretched it out at all that much because the very next line after this is 2 pi. Everybody agree? So I haven't really stretched my graph out very much except for the fact that before this line was here. This was my pi over 2 line, right? And this was pi, 3 pi, and 2 pi was here. So if 2 pi is here, then this whole graph would have been way over here if I'd numbered it the way I've been numbering them and using these 4 lines for 2 pi. So it looks like I stretched it out, but it really isn't stretched out. It's just I had to number it with a scale that I can see, and I can't write that small. It's shifted to the left 1 line because it's not on the origin anymore. So adding and subtracting in the parentheses shifts it left, right. The amplitude stretches it up and down. The scale factor in the period part of the problem affects also how kind of the accordion thought. Squeezing it in and pulling it out, squeezing it in and pulling it out. If there's a number in front of x, this one didn't do that because this one didn't have a number in front of x. But it looks like kind of like it did because I had to make it big enough I could write. And that part you don't see when you hand draw. Hold on a minute. I'm going to move to cosine. I might come back to those later. So we've missed out on one little thing. We haven't seen what B did yet, have we? What have I not done?
Y.
Yeah, I haven't done something a lot to the Y. So we may see what B does in another example in a few minutes. All right, so cosine and sine are almost identical in what you do. There's just one difference. Cosine's an even function and it doesn't start on the origin. So if you can get in your mind where it does start, all the math's done exactly the same. You find the amplitude the same, the period the same, the shift in left and right is the same, the values, everything you do pretty much is the same except that one piece. Cosine is an even function, and so therefore I have to figure out where to start it so that it doesn't start at the origin. And I'll explain why. When you look at a sine wave versus a cosine wave, sine's here, right? But cosine at 0 is 1. Everybody see the problem? I'm not starting on the axis. My shape would be different. But I want it to be the same. Cosine is not the same exact x placement, but it looks the same shape, doesn't it? That's because cosine is a shift of sine. Cosine and sine are functions that are shifts of each other. That's why 60 and 30 degrees have the reverse numbers in the points. So in order to make that happen, we have to back up one line to get it to come back to this point over here on the x-axis on the left side, so that it starts on the actual axis and not up at the top. And that's the only difference between sine and cosine. So this is still amplitude 1. It's still 2 pi divided by 1 is 2 pi. It's still 2 pi divided by 4 is pi over 2. And it's still that there's no phase shift because I don't see any adding and subtracting in that parentheses. But what I do have that's different is how I number the x column. Oh, I didn't even number the y column same. Now, I'll explain why. Let's start off with what we do know. Cosine at 0. If the point is 1, 0, that makes the cosine at 0, 1. Everybody agree? And the cosine up there at pi over 2 is 0. And the cosine over on the left side of the x-axis at pi is negative 1. And the cosine at the bottom at 3 pi over 2 is 0. So these values match up. See how they're off-centered? 0 is not at the top. So that's why we have to go back a line and say this one is negative pi over 2. So cosine always starts on the negative value of the scale factor. So it's on the negative value of the scale factor. Because you're going by that, so you got to back up one line. But at least the y column's the same. And that is the only difference between cosine and sine, is that you start back one line. Everything else is the same. The shape is the same because it's a wave. They're both waves. It's just the start of the x-axis is in a little different place, is the only difference. So as long as you remember to start your table on the negative of the scale factor, you're good to go. It's the same exact thing we just did with the other. So to prove that, we're going to look at a few samples with numbers in different places, and I'll try to throw one in this time that has a B in it. And I may not do 2 of every one of them either, because we're short on time and we've already seen what they do. So we're just going to throw in one here and there of each thing. All right, so let's first look at, again, what happens if the number in front is there. And I threw a negative in on this one so that we could have that also. All right, so what does that negative do again? Yeah, we're going to flip that thing. We're going to reflect it. And what is that, 3, tell me? That's right. And if I get 3 times taller, what does that, that makes me look like I'm tall and skinny, right? So we're going to vertically stretch that thing so it'll look tall and skinny in that funhouse mirror. Now, 2 pi is still divided by 1 because there's nothing right here for omega. And of course our scale factor is still halves because we're dividing by 4. And no phase shift because I don't see any adding and subtracting. We'll do some of that maybe in the next one. Now, this one over here is easy to number because we know those numbers from sine. It's the same answers for sine and cosine. And then our x's, we're going to start on negative pi over 2 because our scale factor is pi over 2. And we're going to go by halves. And last but not least, why this is different than the other one is I got to times by negative 3. Now that you got to be careful about. When you go back to figure out what to multiply by, make sure you go back and pick that up out of the original problem, not just the amplitude, because it was negative 3 in front of the problem, multiplied to cosine, so you've got to multiply by negative 3 in your y column. Because the negative and the 3 are affecting the graph.
I thought you threw away the negative.
You do that for the amplitude, but you don't do that for the whole problem. If you throw it away for the whole problem, it won't reflect. No, I did it again. Thank you. I can't talk and write at the same time today. It's pretty bad. Every other one of them has to be 0. So if you don't multiply by 0 correct, it'll be real obvious real quick because you won't be every other one 0. But if there's adding or subtracting in the problem, sometimes that might change. But when you're typically just showing some multiplying, make sure every other one's 0. So we got our negative pi over 2 here, pi over 2, pi, and 3 pi over 2. And we got 1, 2, 3, 1, 2, 3. Again, remember I give you points for numbering things and labeling things. So when I look at a problem like this, it's usually worth 10 points. One for each of these being written out what it means. You get some points for filling the table correctly, and then numbering it and plotting it correctly. You get some points for each axis. So if you start over here at negative pi over 2 at 0, then 0 is going to go down to negative 3. Then pi over 2 is going to be 0. Pi is going to go up to 3. And then 3 pi over 2 is going to stay at 0. So that it definitely looks much, much taller and vertically stretched. But it also is the reverse of what it should be because it's been reflected. So that's what happens when you look at that number out in front of the word sign. It's all about stretching or stretching it vertically or pushing it down to make it shorter looking when you use smaller numbers, or it reflects. Now, let's look at what happens if you have something on the inside of x. And I chose to put a negative in there also because it could have a negative in there. And I chose to put a fraction just so that we could look at one with a fraction because we haven't looked at x having a fraction on it that much. So when I have cosine of negative pi over 2x, I have to think about that negative first. Cosine is an even function. What's the negative inside there going to do? Yeah, we're going to throw it away. So this problem is going to become cosine of 1/2 x because it has the same answers as cosine of, with the negative on it, of 1/2 x. Because it's an even function. Negatives inside don't affect it. What's my amplitude? 1. Now this time I got to go 2 pi divided by 1/2. That means I got to go 2 pi times the reciprocal. And my graph just got a whole lot longer across the x-axis, did it not? And then you got to take that and divide it by 4 because you always divide your graph into 4 equal pieces. And so we can number by pi's. At least we get to number by whole numbers. Right? Do you see any adding or subtracting in here? No. I see multiplying, but I don't see any adding or subtracting. So there's no phase shift on this one. We'll look at one in a minute that has phase shift. So again, when you number your cosine graphs, you're supposed to take your scale factor, put a negative on it, and start your table there. And go by that scale factor. So it starts at negative pi because that's our scale factor and goes by pi's. And then, that looks a little too far away. Then on our y column, since our amplitude is 1, is that going to change our y values from our original set?
No.
No. And because it's an even function, neither did that negative on the inside change anything. So what we got it numbered by is what we go by. So we start at negative pi is 0. We go up to 1 for 0. Come back down, pi is 0. 2 pi is going to be negative 1. And 3 pi stays at 0. It did not reflect. And I really don't see that it stretched out on the x-axis because we're not numbering it correctly based on, and I hate to say this, but do you know what our x-axis would have to be for us to be able to truly say every graph was stretched horizontally or not? We'd have to be going by twelfths. Can somebody tell me why? Yeah, the unit circle is divided by twelfths, and almost every problem would have denominators with 3, 4, 6. It would work with twelfths. And I sure wouldn't want to number that to twelfths, because that would be a pain. But what it does show you on this problem that we could not see previously is the problem does not always stop on the period, now does it? So let's again talk about what does the period mean. The period is the distance from this value, negative pi, all the way over to 3 pi. So from 0 to 3 pi is 3 pi long, and from 0 to pi being negative is a pi long, and together that makes 4 pi. The distance between the first number and the last number has to subtract to give this. Well, see, in sine, it always stopped on that number, didn't it? But it doesn't always stop on that number. That is what's supposed to represent the distance between the first and last number on your table. Because 3 pi minus negative pi is 4 pi. All right. Okay, we're going to look at a phase shift. And then right after that, we're going to look at one that has a number for B, since we didn't look at a number for B on sine. So this problem actually is going to have a little bit more going on, because it actually shows multiplying and adding. Multiplying does one thing, adding does something else. And because of that, when you put them together, they can affect more than one thing in your problem. But guess what my amplitude is? 1. What's my period? Well, let's take this 4 for omega and say 2 pi divided by 4 is a half. And then let's take that half and divide it by 4 equal pieces. Yep. Because you flip and multiply, and that turns out an 8. So we're going to have to number by 8s. Oh, well, that's okay. Then you take that 4x plus pi and set it equal to 0. And this is what's kind of interesting. You use that 4 to help you figure out the period and what the scale factor is, but you have to have that 4 to figure out your phase shift, because it affects that. So if I take that and subtract pi and divide by 4, then what does this negative pi over 4 tell me? What's this negative tell me? It's going left. So my graph is going to have to shift to the left pi over 4. But my graph is going by 8s. So we're going to have to number and do some math here. Now, again, your 8th here is what you're going to look at for the scale factor to go by. So you always start your table back one line on cosine and go up by 8s. 2 8s is a 4th, 3 8s. But your scale factor is what you do to that value. So I'm going to take off pi over 4 so it'll go left. So minus pi over 4 from each one. Now, sometimes you may look at some of these and you say, hey, I know the answer to that one. This one's negative pi over 4, and this one's 0. You may see that just right away. If you don't see what the answer is, get a common denominator. How many eighths is a fourth? So if I have negative 1/8 that I minus 2/8, what do I have? All right, it'll be negative. Now, I already wrote it in this answer, but how many eighths is that answer? That's right. So if this is negative 3/8 and this is negative 2/8, want to take a wild guess what this one is? Well, let's see. This is 1/8 minus 2/8. What's 1 minus 2? Negative 1. Now, do you see the pattern? Negative 3/8, negative 2/8, negative 1/8, 0. It's going by eighths. 1/8. So just because I took a number away, that number was able to be turned into eighths, made me able to see that it's still going by eighths. Now, that's not always the case. It may not continue to go by that scale factor sometimes because of what values you have, but it should most times show that. Now, this problem doesn't have any amplitude to work with besides 1, so my values on this side did not change. The only thing that changed was my x's because I had a parentheses with a bunch of stuff inside there affecting x. But there's nothing outside the parentheses to affect y. So in this problem, this line here has got to move over because I need more negative. See, negative 3 pi over 8, negative 2 pi over 8 is negative 1/4, negative pi over 8. These values actually do go by 8, so I can put every line. And then you got pi over 8 over here. And then 1 and negative 1. How come I knew where to put them all without looking at the table? Yeah, it's a pattern. So I knew it didn't reflect, so I knew I was going to go up first. Every other one's on 0. So now let's look at an example of a problem in which there's a number on the end. And let's see how does that number on the end of the problem affect it, because we haven't looked at the position B. So in this problem, the only number I put in was minus 3. And the reason I put that in is because I wanted you to be able to see just what that adding or subtracting number on the end does. So my amplitude is still 1. 2 pi is still be divided by 1 because there's a 1 in front of x for omega and there's a 1 in front of the whole problem for the amplitude. What does that make my scale factor? Pi over 2. And there's none because I don't see any adding or subtracting inside of a parentheses. Everybody agree? So scale factor, a phase shift, there's none. So this problem did not reflect. It did not move left or right. Everybody with me so far? It did not stretch vertically or get compressed vertically. So what in the world does that minus 3 have left to do that we haven't already talked about? Yeah, that B is got negative 3 is going to affect that y-axis values. It's definitely going to affect our y-axis values. So we're going to see another thing that transformations do that I'm sure that once you see it, you'll say, oh, yeah, that's what they do. All right, so we're going to start on negative pi over 2. Why? Right, sine starts with 0, but we got to back up 1 from 0 because cosine always starts on the negative side. Now my period is still 2 pi, because if I take 3 pi over 2 minus negative pi over 2, that's 2 pi. So the period is still matching up. You got another one?
Yeah.
Wow. So this minus 3 is outside the trig. So that's why it affects y. And you minus 3 from each one. Now notice that there are no zeros now. But what I do notice is that every other one of them is the same. And since we need one negative value, I don't have to move my axis this time. All right, so negative pi over 2 is negative 3. So that's here. 0 is negative 2. So we go up a line. And pi over 2 is negative 3. And pi is negative 4. And 3 pi over 2 is negative 3. So it still has that concept of like that imaginary line going through the middle of it, except now it's at negative 3. So now, if you had to describe to somebody what B does to a question, what would you say? That's right. Minus than 3, it went down 3. So I guess if I add 2, what would it do? Exactly. Same thing we've studied for years about up, down, left, right. The numbers on the end of the problem always move it up and down. The numbers inside the parentheses always make it go left or right if there's adding or subtracting. But we also had the situation of the number in front of x and the number in front of your amplitude also doing other things. All right. So that's kind of where we have looked at all the different positions now and what they do. So to wrap up our lesson, why does it keep going backwards? Let's look at one example of what if it's doing everything. And I chose to do cosine because I just thought it didn't hurt to practice one more cosine since they don't start on 0. Because you could have a problem that has lots of stuff going on. So negative 2 cosine of 4x minus pi plus 1 on the outside has a lot going on. It's going to do it all because it has something in every hole.
Yeah.
Yay. So what does this negative do? When I mean what does it do, I mean I can't drop it. It's not inside the parentheses, y'all. It reflects. Okay, the big difference here is, let me show you something. If I had cosine of negative 4x plus pi, that negative I'd have to take out. And if I take it out, I have to take it out of all of it. Okay? So if I wanted to take this negative out, it would throw away. But then that would become 4x minus pi because you got to take it out of all of it. This one I can't do that because in this one it's already out. And you can't drop it if it's already out. All right, amplitude.
Negative.
Yeah, it's got to be 2. It can't be negative. Now, 2 pi is divided by omega. Here's your omega. So we're dividing by 4. And our period is just a half pi, so that's not very long, is it? And if I divide half pi by 4, we already have learned that's 8ths. Phase shift. What is 4x minus pi equals 0? Correct? because you add pi and divide by 4. So I made it go to the right, pi over 4. And what's this 1 on the end going to do? Up 1. So there are two things in your formula that you have to write near your formula to tell you what it does, where the rest of it gets written with these different things that relate to the trig. All right, let's focus on x. What value do I start my x's on in cosine? The 1 before 0. In this case would be? Correct. Negative pi over 8. Then we're going by 8s. Now, I could have made some that were a lot nastier than these, y'all, because if you put a 3 in front of that x, it takes a whole lot more common denominator work. All right, now we got to shift it to the right, pi over 4. How do we do that? That's right, we got to add pi over 4. Now, we got to think of that as 2 8s, right? All the way down, we're going to think 2 8s because it helps to have the common denominator. So what is negative 1/8 plus 2 8s? Pi over 8. Now, we don't have to think that on this one because this one just comes out of 4th. 1/8 plus 2 8s is 3 8s. What's a 4th plus a 4th? Half. All right, 3 8s plus 2 8s, 5 8s. And if you've done it right, you could go back and think 8s for all of it, and it should be going up by 1/8 each time, looks like. Well, that makes sense. That was a scale factor, right? Now over here, these are our original numbers. We're going to talk about that. Okay, when you are trying to figure out what this side of the question does, here's a little clue. Think about that this whole little piece right here is a blank. It says negative 2 times the cosine plus 1. So do negative 2 times all the values you wrote in your column and plus 1. Because that's what you're doing. You're taking out the cosine with that parentheses and you're putting in the answer for cosine. So you're doing negative 2 times this plus 1 on each one because that's what's outside the trig. So anytime you have amplitude and up and down motion, you've got to do both of those operations to the number. So you times it by 0 and add 1 and get 1. Negative 2 times 1 is negative 2 and add 1 is negative 1. This one times 0 is still going to be 0 plus 1 is 1. Negative and negative make a positive 2 plus 1 is 3. 0 times anything is 0 plus 1 is 1. So at least every other one is still the same. And because all my values for my x column are now turned to positives now that we shifted to the right, we got to number it by 8s, which is what my table actually is numbered by, which is nice. And then we got to go up to 3 and down to negative 1. So we start off with pi over 8 is 1, and we work our way up and down to make the curve. So pi over 8 is 1. Pi over 4 is negative 1. 3 pi over 8 is 1. Pi over 2 is 3, and the last one's back down to 1. I'll put that in the right place. So our graph does look somewhat stretched vertically. It does look like it shifted to the right. Does everybody agree? It does look like that it moved up 1 because the line that it's going through the middle is up 1. It's not on the x-axis anymore, and it does look reflected because it's upside down. So it did everything we wanted it to do. All right. Now, tomorrow I have to give the work keys test. And so what I thought I would do is give y'all an assignment on this for you to do out of Canvas. But I have one out there right now I'm not real happy with, so I may make some changes to it because it's good, but I think I want to put some different directions and things to put with it because it seems a little long. So I may make some changes to it, so you won't start the assignment until tomorrow, and you'll work on it the whole class period while I give work keys. Now you'll be next door in Miss Bennett's room because she has planning this period, so they had to have somewhere to move y'all to because I'm giving the test in my room. So you'll have an assignment in Canvas tomorrow, but don't open it tonight because I'm going to make some changes to it, and I've ran out of time today to be able to make those changes.
Hi, Lynn Pitt, please come to the office.